Hello everyone, this is Aditya and today we'll cover integral calculus for N-term Btech. So in this we'll cover like two topics, the convergence test and beta and gamma function, right? So in this we are gonna cover all this and please do like, share, subscribe my channel, and I'm a bit not well, so that is why kindly bear with it. And now let's start with the topic. So let's start with the convergence test first. So like you all know that what is improper and proper integral. Let me give a gist of that, but it is not really important, so that is why I'm skipping all that. And like mean by theorem and all, everything is there. I might cover in the on Saturday Sunday lecture, right, a bit of that, but it is not important. So kindly the topics which are missing, which I am missing, maybe they are not important, somewhat like that. Okay, so kindly bear with it. And now let's start. Okay, so first of all, let's see what is improper integral, right? Suppose an integral of the form negative infinity to a fx dx, or suppose negative infinity to infinity of fx dx, or b to infinity fx dx, right? Or suppose a to b fx dx, but there exists some c belonging to a to b such that f at c is not defined. So in such cases, we say that the integral is improper, and we need to cover and we need to take the limiting case in that. For example, in this we will break the limit from a to c, then from c to b, and then add them, right? And in this case, we will use limit as r tends towards infinity of negative r to a, right, like that. But it's really not a big deal. You all know this, so I'm skipping this part because it is a bit logical also. And even if you don't use that, it won't affect. But at last, when you substitute the limit, it will be like you have to use the limits, right? When you substitute the integral limits, then if it's infinity or it is breaking at somewhere, then it's obvious you will use the limiting case, right? So I don't think so that it is much need to be taken care of. You all can understand it. But basically, like if it's a to b fx dx, you all know that it will be equal to limit as b tends towards infinity of a to b of fx dx, and you will integrate it, right? It's obvious, right? Okay, so now let's come into the convergence test. That is the really important topic of today's video, and then the beta gamma function, and that is really important, right? So let's start with the convergence test, and then we'll move to the beta and gamma functions. So I hope you all are understanding it. Okay, so now let's start. Okay, so let's see the comparison test. The first one, comparison, right? So we'll study the comparison test first of all, right? So in that case, and I have to be a bit fast because we don't have any time, and I have to make the other lectures also for multiple integral and for the application of integrals, right? So this is like for in this from this lecture you might score from like 10 to 15 marks. Obviously, it's obvious since beta and gamma function carry a huge weightage, and the convergence also, it is obvious that it will come, right? Okay. So the best thing about the convergence test is that it is somewhat relatable to the sequence series term, the sequence series convergence, right? In that case also we used to use the ratio test, somewhat like that, comparison test and all, right? So the same thing we will use over here, but as in a different reference. Okay, let's see. Suppose fx sorry, suppose your fx is given and it is less than gx, right? And you have to check for the convergence of fx convergence. What does it mean? If fx is less than equal to gx, then doesn't it imply that integral from a to infinity of fx dx will be less than integral a to b a to infinity of gx dx? Doesn't it imply, because since they both are positive always, so there is no chance that the integral will go downwards, then there might be a subtraction of area or somewhat like that. It's no chance. So that is why in this case we will get that we'll get this inequality. So what does it imply? It implies that if this integral converges, then it implies that this integral will also converge. Why? Because if something greater is converging, it will imply that something smaller will also converge, right? I hope you are understanding it. Okay, so I hope you are understanding it and it's not a bit fast. Okay, if you have any doubt, you can comment me, right? Okay, and I will cover that thing. Okay, and notice that this is smaller integral. So if a smaller integral will diverge, then this will imply that the greater integral will also diverge. because if the smaller thing is diverging, that is obvious that the bigger thing will also diverge, right? It's a bit logical, so I'm not going deep into it, right? We will see it in the later part. Okay, this is the basic idea. Okay, and it is somewhat related to sequence series lecture also, which I've taken, the comparison test which we used in that. Sorry. Now we will use the limit test. Okay, so now we are going to use the limit test. How we use it? Okay, suppose fx and gx are two functions, right? They are integrable functions. Okay, means they are not breaking anywhere, right? Okay, so we say that limit as x tends towards infinity of fx upon gx is equal to lambda, and lambda is a finite value, right? So lambda is a finite value. Okay, given lambda is a finite value, so it implies that they both will either converge together or diverge together if lambda is a finite value, which means that if fx converge, that implies that gx will also converge. If fx diverge, it implies that gx will also diverge, and if gx diverges, then it's vice versa, right? If gx diverge, it will also diverge. If gx converge, it will also converge. If this converges, this converges. This converges, this also converges, right? Okay, so that is the thing, basic idea. Okay, so now let's see another test, and that is really important, and I will tell the reason also behind that test, why we basically use it, right? Okay, so now we are going to start with the mu test, and that is really important. So mu test we will study for two cases: integral a to infinity of fx dx integral, and the second thing for integral a to b fx dx, right? In these two cases, when this is improper, this is proper, right? So in case of proper integral, it will be different. For the improper, it will be different. And to a great surprise, this is somewhat related to the ratio test. How? I will discuss it. So let's start with the first condition. First of all, the improper one. Let's see how it goes. Okay. So basically, you get this thing. Okay. In this, you assume gx as equal to 1 upon x to the power mu. So by this mu term out of nowhere. Well, let's see. Basically, we define our function 1 upon x to the power mu, and in this case, we evaluate using p-test. You remember in sequences we used to use p-test. Somewhat it is relatable to that, but not exactly it is that. Okay, we will see how. Okay, so don't panic. We will study and we will see clearly. So limit as x tends towards infinity, where mu is a real value. Okay, don't forget it. Mu belongs to real numbers. Obviously, it can't be imaginary for our case basically. So in this, what we are getting is that. So as limit x is tending towards infinity, what we are getting, sorry, there was some disturbance, that is why. Okay, so what I was saying, that limit as x is tending towards infinity of fx by gx, it must be defined, right? This is the idea, right? So it will be equal to limit as x tends towards infinity of fx upon 1 upon x to the power mu, and it is equal to limit as x tends towards infinity of x to the power mu of fx dx, and suppose it comes out to be lambda, where lambda is some finite value again, like in the ratio test. That is it. Okay, so if this comes out to be lambda, so in that case a finite value, so this integral 1 upon x to the power mu, it converge for mu greater than 1, and it diverge for mu less than 1, right? So we know that from the ratio test, if gx is converging, then this will also converge, and if it's diverging, then this will also diverge from the ratio test, that they both go together, which means this is convergent for mu greater than 1, and this is divergent for mu less than 1, right? I hope you are understanding it, and why it works, let's see, because we need to know the reason also, since it helps a lot, right? Don't worry, it won't take much time, just 1 minute. So as an integral a to infinity 1 upon x to the power mu dx, you write it like this. To convert it from improper to proper, you write it as b tends towards infinity of a to b of 1 upon x to the power mu dx. You get this thing, and now what's next? Well, let's see. What's the next thing which we are gonna do? Well, let's see. Simply integrate it. What do you get? Limit as b tends towards infinity of 1 upon 1 minus mu into 1 upon x to the power mu minus 1, and the limits a to b, right? Just solve it, okay? You will get this. Now you just substitute it like this. Limit as b is tending towards infinity of 1 upon 1 minus mu of 1 upon b to the power mu minus 1 minus 1 upon 1 minus mu into 1 upon a to the power mu minus 1. Don't be in a panic. I just substitute the limits, right? And take a difference, okay? Nothing else, okay? So basically you can make this a plus and make it mu minus 1, right? Is it correct? Okay, is it correct? Yeah. So in this case, observe that this is a finite quantity, but the problem is over here. For 1 minus mu also it's fine. We have to check for limit as b is tending towards infinity of 1 upon b to the power mu minus 1. So notice that if you take something greater than 1, in this case, what you will get? You will get 1 upon infinity, right? 1 upon infinity to some positive power. So if mu is greater than 1, then in that case the limit as b is tending towards infinity of 1 upon b to the power mu minus 1, it will tend towards 0, since it will become 1 upon infinity to some positive power, right? So it will remain in the denominator. So 1 upon anything 1 upon infinity to the power some positive power, it will go towards 0, right? But if mu is less than 1, then limit as b is tending towards infinity of 1 upon b to the power sorry, I said no, I'm not well, that's why. So in this case, when mu is less than 1, it will become mu minus 1 and it will become a negative quantity. So 1 upon b raised to 1 upon b raised to power some negative quantity, you will get this. So some negative quantity 1 upon infinity raised to some negative quantity, it will tend towards infinity. So that is why it will diverge for mu less than 1 and will converge for mu greater than 1. Okay, so that is how you prove it. Okay, that's the basic idea of the mu test for the case 1. Now let's see for the case 2. Okay, I hope you are understanding it. It's like very basic, the integral. Okay, it's just a fancy way to call integral like proper, improper, somewhat like that. Okay, but I don't care much about it. Nor you should also. You should just work on the questions and how to tackle them. Okay, this is the basic idea. Okay, so now let's see another type, integral a to b fx dx. So in this case we have to check the convergence of this function, right? So how we'll do it? Okay, let's see. So what we'll do in this is that we will assume a g of x the same as that, but with a difference of a, x minus a to the power mu, right? Just assume it for the time being. And when you apply the ratio test, you get fx upon this quantity, you will get x minus a to the power mu of fx. As x tends towards infinity, this will be equal to lambda, and it is a finite value. If it is a finite value, then this expression, see, gx is convergent. In this case, for mu greater than 1, it will diverge, and for mu less than 1, it will converge. Now many ask me that why opposite in this case? In that case, it is like it is for positive value, for mu greater than 1, it is converging, and why in this case it is diverging? Well, let's see how we will do it. Okay, so let's see. This is the basic idea which you know. Now we will see the proof. Okay. So let's see the basic idea that integral a to b of 1 upon x minus a to the power mu dx, right? Okay. So what you are getting in this, you integrate it, you will get 1 minus mu as a common, and you get limit as x tends towards like when you substitute b, it's okay, 1 upon x minus a to the power mu minus 1, right? To as it goes from a to b, right? So 1 upon 1 minus mu of 1 upon b minus a to the power mu minus 1 minus, notice that if you substitute a directly over here, you will get 1 upon 0, which is not possible, right? To have a denominator as 0. So you substitute limit x tends towards b of what? Let's see, of 1 upon x minus a to the power, sorry, limit as x tends towards a. And I'm really sorry, there's one problem there. When I said x minus, in that case we will apply this limit as x tends towards a positive of fx by x minus a to the power mu. Notice that in this we will take this for the second case. I am really sorry, it will not be from infinity, it will be from limit as x tends towards a plus, x is tending towards a positive, right? So in that case it will be fx by x minus a raised to the power mu, and in that case we will get a lambda, right? So in this case we are going to get a lambda. Okay, it is not that, it is not this. Okay, remember this. I am really sorry, it is 1 upon this quantity. I am really sorry, I am not well, that's why. So this is not the case, this is correct. Limit as x tends towards a positive of fx into x minus a to the power mu is equal to lambda, right? This is the case, remember it. Okay, this is correct, not that. Okay, remember it. Sorry, I am really sorry for that. I will correct it in the later part of the video also, okay, if I made any such mistake. Okay, so basically you got this thing, and now what's next? Okay, so just observe that limit x tends towards a of 1 upon x minus a to the power mu minus 1, right? So notice that if mu is greater than 0, so 1 upon 0 to the power some theta, suppose, where theta is greater than 0, it's obvious that it tends towards infinity, right? For mu greater than 1, right? Since 1 minus something greater minus 1 is always positive, and 1 upon some 0 raised to the power some positive power, it will go towards infinity. And for mu less than 1, it will 1 upon 0 to the power some negative value, some negative theta you can say, and this goes towards 0, which means this integral is defined for mu less than 1, is convergent for mu less than 1, but is divergent for mu greater than 1, right? I hope you understand why there's a difference. Okay, that's the idea. And one thing to be noticed that if fx is this integral a to b fx dx, so it will be limit as x is tending towards a positive of fx by gx, right? And where gx is equal to 1 upon x minus a to the power mu, right? Remember it. Okay, I made a mistake over here, I wrote infinity, it's not infinity in this case, it's a positive, right? Okay, so now let's see if there is any other test, or we will start with the question. Okay, let's start with the question only. So I'm a bit fast right now because there's a lot of things to be covered, right? But I will make sure that you all understand it, and if you don't understand, you can comment or message me. Okay, so now let's come to the first problem of it. Question number 1, the show that this integral is, check whether this is convergent or divergent. We have to check this. Okay, so now we discussed about mu and p test in sequence, series and integrals. But how we calculate the mu in this case? Well, you take such mu such that when you calculate, you try to get a finite value, right? How? Let's see. Or basically you take from the ratio, you get gx as x to the power 3 by 2 upon this x square, simply you get 1 upon x to the power half. This is your gx, and mu is equal to negative 1 by 2, right? And mu is equal to 1 half, right? You got this? Why didn't I took like 1 by 3 or somewhat like that? Sorry, like 3 by 2 or somewhat like that. Because if you put 3 by 2, for example, x, for example, 5 by 2, I take gx as 1 upon x to the power 5 by 2. Let's see. 3 by 2 by 3x square plus 5 into 1 upon x to the power 5 by 2, right? You get this, okay? You will get like it will go upwards, it will go x to the power 4 by 3x square plus 5 as x is tending towards infinity, and notice that it will go towards infinity, right? But we try to make such things such that we get a lambda as a finite value. So that is why we will use x to the power halves. In that case, we will get a finite value so that we can easily test the convergence test, right? Let's see. We are basically choosing such a lambda, right? Such a mu, okay? Basically. So in that case, it will be limit as x tends towards infinity of x to the power 3 by 2 by 3x square plus 5 upon gx. Gx is this quantity. 1 upon x to the power half, you get x to the power x square by 3x square plus 5 as x is tending towards infinity, and it is equal to 1 by 3. This simple limit you can use L'Hopital rule also, or you can simply use the limiting case, right? That is very easy. Okay, you can bring x square downwards and like that. Any method you can use. This is a basic limit. Okay, I am not going into it. Okay. Right? Is it correct? Okay. So it is a finite value, which means they both will be either convergent or divergent. So for mu equal to half, and this is an improper integral, so in this case mu is equal to half, which is less than 1, so it is a diverging integral. Gx is diverging, so this is also diverging, hence proof that is a diverging. Okay. Okay. So now let's see another question. Sorry, there was some disturbance, and now let's see the question number. Let's see the question number 2 now. Okay. So the question is like we need to evaluate integral. We have to show that this integral is convergent, right? So in this I'm not covering two high level questions because there's very less chance that they will come even. So we are discussing the basic idea that how the things go, and we are evaluating the things and building a concept. And now in 1 or 2 days before the end sim, I will make a one shot of 1 or 1.5 hour. In that I will cover all the questions from the Rolle's theorem to the multiple integrals, right? So it will be very easy for us to understand the concept. So like this, we are given that fx is equal to this thing e to the power negative x square. So in this case, we are going to assume gx is equal to x square, right? It will be easy for our calculation, right? Okay. So how we are going to evaluate it, right? You can assume 1 upon x square, you can assume any quantity, right? It don't matter. For the simplicity, we have assumed 1 upon x square, okay? So basically now we will apply the ratio test, limit as x is tending towards infinity of fx by gx is equal to the limit as x is tending towards infinity of e to the power negative x square by 1 upon x square. You can just simplify this and you get limit as x is tending towards infinity of x square by e to the power x square, right? As you notice that if you take x cube or x to the power any value, it don't affect, right? Okay, that's the thing. So I prefer to take a positive value in this case, means it is easier for us to calculate, right? So this thing is tending towards 0, it is a finite value, right? Okay. Since it is finite, which means they both will be either convergent or divergent, right? Okay. In this case, the mu is greater than 2, greater than 1, and it is an improper integral. So which means that this will be convergent. So which means this is convergent. So this implies that this will be also convergent, right? Hence proof. Okay. Now let's see one more question, and then we'll move on to the beta and gamma function, right? Because that is the heart of this chapter actually. So let's see the question number 3. For now, 0 to pi of sine of x by x cube dx, right? So notice that in that case, what will happen is that the limits are defined in both the cases. So in this case, we'll assume gx is equal to 1 upon x square. Why 1 upon x square? Why? We will not assume 1 upon x square. We will assume 1 upon x minus a whole square, since we try to find such a value such that the lambda is defined, right? If you substitute x square over here, it will sin x by x as x is tending towards 0. Here it is 0, right? Why? Because it is a proper integral, right? So here a is equal to 0. So 1 upon x minus 0 the whole square, which is equal to 1 upon x square. Which means limit as x is tending towards a positive, that is 0 positive, of fx by gx is equal to sin x by x cube into 1 upon x square, which is equal to limit x tends towards 0 positive of sin x by x, right? This will be the case. I hope you are understanding it. And this is equal to 1. And since it is equal to 1, it is a finite value. So which means if this converge, then this will also converge. So notice that in this case, the mu is equal to 2, which is greater than 1. But notice that in this case, it is a proper integral. So in this case, when mu is greater than 1, in that case, it will imply that this expression is diverging, which means that this will also diverge. I hope you are understanding it, okay? So now let's see if we have any other question left, or we can directly move on to some other topic, right? So let's directly move to, there's a Cauchy principal value which we need to study, then we will move to gamma and beta function, right? And it's really an interesting function, right? to start with. And don't worry, we will do one shot questions also, so it will everything will become clear more. So let's see the Cauchy principal value. What is it? States that it states integral negative infinity to infinity of fx dx is equal to the integral as r tends towards infinity and r tends towards 0, right? This is the case of integral negative r to some quantity x minus r. This is your x minus r plus integral x plus r to the power r fx dx, right? Are you understanding it? And this will be fx dx of course, right? Okay. So this is your Cauchy principal theorem, but I don't think so there will be any question from it. But still, I have told if it comes, you can solve it. Okay. Okay. So now let's go to the gamma and beta function and let's start with this. Okay. So let's see the gamma function and the beta function. Gamma function, right? Let's see, and let me change the chalk. Okay. So this is the integral. It states that the integral 0 to infinity of x to the power n minus 1 e to the power minus x dx is equal to gamma of n is equal to n minus 1 factorial, right? This is the case. Okay. Okay. So notice that why is it true and why we are even bothered about it, because this function is used to define the gamma values or the factorial values of negative numbers or even the fraction values, right? We generally study fractions, we generally study the factorial terms in the cases of permutation combination. So it is really absurd to think about something like a fractional factorial, like it's something really out of the reach of humanity. But in quantum mechanics and data science, many times we are like encountered with such problems. So like that, so that's why gamma function is so much important, right? Okay. So let's see a proof of this, that y is it equal to this. Okay, let's see. Integral 0 to infinity x to the power n minus 1 e to the power negative x dx. So just assume that this is your first function, this is your second function, and just use integration by part. Okay. So what is it? X to the power n minus 1. What is the integral? It will negative e to the power negative x as it goes from 0 to infinity. Obviously, you will use limiting case over here, but I'm not using it, but you should use, right? Minus integral 0 to infinity. Let me break the chalk so that it's easier for me to write. Of n minus 1 into e to the power negative x, and a negative x will come in the denominator, which make this plus x to the power n minus 2 into dx, right? This is the case. And notice that when you substitute, when you do it like this, it will become x to the power n minus 1 by e to the power x 0 to infinity. Notice when you substitute 0, you get a 0. Limit as b tends to, as x is tending towards infinity, of negative x to the power n minus 1 upon e to the power x. This exponential is the increasing function in comparison to this function, which means this will go towards 0, right? Minus minus plus, this will become 0 by some e to the power 0, which is becoming what? This is becoming 0. So basically this expression is this. How we write it? Let's see. We write it further that this is n minus 1 into integral 0 to infinity of x to the power n minus 2 into e to the power negative x dx. And to a great surprise, you will observe that this is equal to n minus 1 into gamma of n minus 1, right? Don't you agree to it? Yeah. You just make it like this, n minus 1 minus 1, right? So it is gamma of n minus 1, right? Okay. Which means that you proved a relation, this, that gamma of n is equal to n minus 1 into gamma of n minus 1, or gamma of n plus 1 is equal to n into gamma of n, right? Okay, and I hope this was asked in your test also, right, yesterday, I guess, in the CA, right? So, but what we have to do from this? Well, you substitute another thing, you will get n minus 1, n minus 1 into n minus 2, so on and so forth till gamma of 1. 3 into 2 into 1 into gamma of 1. And what is gamma of 1? It will be, it is 0 to infinity of, you substitute 1, you get x to the power 0. So e to the power negative x dx, and it's a very simple integral. When you evaluate it, you will get it 1. So this is 1, right? Okay. So you get gamma of n is equal to n minus 1 factorial, right? Hence proved. Okay. Now let's see some problems. But before that, we need to study the beta function also, right? Let's study beta function and then we will move to the problems, right? And okay, let's see. So beta function, beta, it is a multivariable function actually, and it is equal to 0 to 1 of x to the power m minus 1. We generally use t also, so it don't matter. 1 minus, but it, c variables can be any, okay, 1 minus x to the power n minus 1 dx. This is your beta function. Okay, sometimes we use it in reference of a sine and theta function. How do we check it? Let's see. Okay, obviously m and n are positive. Okay, okay, okay. Now substitute x is equal to sine square theta, right? Okay, limits are from 0 to pi by 2. You substitute 0, you get theta is 0. You substitute pi by, you substitute 1, you get sine of theta is equal to 1. So you get sine, your theta is pi by 2, right? Okay, is it correct? Is it correct? Yeah. Okay, so you get this sine raised to the power 2 of m minus 1 into theta into 1 minus sine square theta n minus 1. What is the derivative of this function? It is equal to 2 sine theta into cos theta, the chain rule. Okay, notice that dx is equal to 2 sine theta cos theta d theta, right? You get this? It is very simple. Okay, 2 sine theta cos theta d theta, right? You get this? Okay, so from this you get 2 times integral 0 to pi by 2 of sine to the power 2 m minus 2 into the cos theta into cos of this 1 minus sine square is cos square, cos square multiplied by this, you get cos of 2 n minus 2 theta. How? See na, 2 raised to power a into b is equal to 2 raised to power ab, right? Notice this thing. Okay, you remember this property of exponents, right? Okay. Just remember some properties, right? It is really helpful for calculation purpose, right? Into sine theta into cos theta d theta, right? Okay, okay. So now let's see, you get 2 of 0 to pi by 2. This just multiply them, you get sine of 2 m minus 1 theta to cos of 2 n minus theta d theta, and this is equal to beta of mn, right? This is another form of the beta function, right? So you got these two functions, right? Okay, so what's the use of this beta function? Well, let's see, it has a very big use. Let's see how. Okay, so let's see, do you know a relation between gamma and beta function? Well, let's see, beta of mn is equal to gamma of m into gamma of n by gamma of m plus n, right? Okay, and beta of m n is equal to the integral 0 to 1 x to the power m minus 1 into 1 minus x to the power n minus 1 dx, right? This is the thing, it is equal to 2 times integral, don't forget this 2, right? This is really important, right? Okay, 0 to pi by 2 of sine of 2 m minus 1 theta of cos of 2 n minus 1 theta d theta, right? And you know the gamma function, gamma of n is equal to n minus 1 factorial is equal to the integral 0 to infinity of t to power n minus 1 e to power negative t dt. You can use x also, it don't matter. Okay, so just observe these formulae, these are really important. right? Okay, just remember these three, these, and this relation is really important. This one is, it's like very important. Okay, so let's see if we can see some nice calculations. Let's see. Actually, I'm a bit very much tired, so that is why I'm trying to be a bit fast, and we don't have time also, right? Okay, so now let's see some problems, and then we will wind up with the things. And with the proof of gamma and beta function, we'll have to see double integrals. Though I can prove it without double integral also, but I don't think so. If the proof comes, it will be like that. It will be like that. You have to prove using double integrals. That is why it's wastage of time right now. But I will surely make a video on it. Okay, how to prove it. Okay. So now let's solve integral a to b of x minus a to the power m minus 1 of the quantity b minus x of n minus 1 dx, and here you need to prove that it is equal to b minus a raised to the power m plus n minus 1 of beta of m comma n. Let me change the chalk first of all. Yeah. Okay. So you have to prove this expression. This is b. Okay. This is b, right? So how do we need to, so how do we prove it? Well, let's see solution. Well, notice that you have x minus a and then b minus x, so it is the alternating type of thing, which means we need to convert it to some polar thing, right? If you remember, you will assume is equal to a sine square theta plus b cos square theta, right? You will assume this thing. Okay. Okay, I hope you are understanding it now. It is very simple, but it is just very much manipulative. That is the thing. Means you have to really think a lot before any calculation. Like the manipulation is really important in this chapter, right? So please do work upon the manipulations and like that. Okay, but like 3-4 manipulations are enough for this chapter. Okay, you don't need to worry much. Okay, so now let's see this. Okay, so just see the limits. It will be changed to like 0 to pi by 2. How? You substitute a in place of x, right? And you will solve, you will get this. Okay, how? Well, in that case you will just substitute a, then you will solve for theta. In that case you substitute b, you will solve for that. Okay, let me tell. So you substitute a is equal to a sine square theta plus b cos square theta, and you get a 1 minus sine square theta, right? Here it will become cos square theta is equal to b cos square theta. Since a is not equal to b, which implies that cos theta must be equal to 0, so cos theta is equal to 0 implies that theta is equal to pi by 2, right? Theta is equal to pi by 2, right? You will get this. Okay, and for similarly you can solve for the upper limit. It will be theta is equal to 0, right? Okay, and when you differentiate it, what you will get? You will get a, it will basically a minus b 2 sine theta minus 2 sine theta into cos theta, right? D theta, right? And you substitute over here, you will get x minus a minus this one. Let me tell how to calculate it. Okay, this is your derivative term. Okay, so now x a sine square theta plus b cos square theta minus a, what it will become? It will, you we can take minus a as a common. You get minus a of 1 minus sine square theta plus b cos square theta, right? So you get basically cos square theta as common, and you get b minus a, right? Is it correct? Yeah, it is correct. So raised to the power this quantity, so you get b minus a, just forget about the limits right now, b minus a to the power m minus 1 into cos to the power 2m minus 1, right? 2m minus 2, right? Into theta. And simply when you substitute this b minus x, what you get? B minus this quantity a sine square theta minus b cos square theta, you get b sine square theta minus a sine square theta, and you get b minus a to the power sine square theta, right? It's a bit long lectures, that's why, of the quantity b minus a of n minus 1 of sine 2 n minus 2 theta into now this quantity, this a minus b into, I have to erase that stuff so that it becomes clear how we are exactly using it. Okay, so let's solve it. Of this quantity into this is 2 sine theta into cos theta d theta, right? Okay, so you are getting this thing, and let's see what we can do further. Notice that the limit was from pi by 2 to 0, right? You are getting this. Okay, so I hope you are understanding it. Okay, and now when you solve it, what you will get is that you solve this, you get 0 to pi by 2 of b minus a to the power m plus n, m plus n, m plus n raised to the power sorry, m plus n means it will be m plus n minus 2 into this quantity. Since why we change the limit from 0 to pi by 2, since it was b minus a, it was a minus b, I converted to b minus a, right? That is the limit it's going to change, right? So I put a negative sign and the limit changed. Okay, b plus n minus 1 sine 2n minus 1 theta into cos 2 m minus 1 theta d theta, right? Of, and we bring a 2 outside, right? So you get 2 times the integral 0 to infinity of b minus a to the power m plus n. Wait, I have to erase this thing. You get b minus a to the power m plus n minus 1 2 of the integral 0 to pi by 2 of so we get the integral 2 into integral 0 to pi by 2 of sine of 2n minus 1 theta into cos of 2m minus 1 theta d theta. And notice that what is this? It is equal to b, and this is equal to the beta n comma m, right? And there's a property of beta function that beta of m comma n is equal to beta of n comma m, right? So we are just going to substitute this, and you get b minus, let me write it upwards, so it will be equal to b minus a to the power m plus n minus 1 of the quantity this thing multiplied 2 also, right? You get beta of n comma m, but we know this property, so we write m comma n, and that is what we needed to prove, right? Okay, so that is the thing. Okay, so now let's see another question. Sorry. Okay, so let's see what other question we can discuss. Well, you need to prove that gamma of 1 by 2 is equal to root pi. How to prove this? It was like asked in your CA also. So how you are going to prove this? Well, let's see. Okay, since we know that beta of m comma n is equal to 2 times the integral 0 to pi by 2 of sine of 2m minus 1 into theta of into cos theta raised by 2n minus 1 d theta, right? You know this. Okay, so in this case and you also know that this is equal to gamma of m into gamma of n by gamma of m plus 1, right? So what you can do is you substitute m is equal to n is equal to 1 by 2 in this to get the following result. Okay, so when you substitute, you get gamma of 1 by 2 into gamma of 1 by 2 upon gamma of 1 by 1 by 2 plus 1 by 2 is equal to integral 2 times the integral 0 to infinity of sine of 2 into 1 by 2 minus 1 theta. I hope you're understanding. We have just substituted m as 1 by 2 over here, like we have used over here, right? Into cos of 2 into 1 by 2 minus 1 theta d theta, right? Okay, so basically when we solve it, what we get is that so on solving, you get gamma of 1 by 2 into gamma 1 by 2, it will be gamma of 1 by 2 the whole square, right? And what is gamma of 1? It is equal to 0 factorial and it is equal to 1, right? So no need to write anything. So it is equal to 2 times the integral 0 to pi by 2. Notice that this thing is equal to sine theta to the power 0. So this is 1, this is 1. So we are left with, it is sorry, 0 to pi by 2 d theta, right? And it is equal to 2 times pi by 2 minus 0 which is equal to pi, right? Okay, what's next? Okay, let's see. So you get gamma of 1 by 2, the whole square is equal to root pi, right? Is equal to pi. We will discuss it later in the later part. Let's see some other question if we see. Okay, let's see some practice questions for now, and we'll end the lecture after that. Okay. Okay, so let's assume this question: does this integral 0 to 1 dx by root x plus x square, does it converge or diverge? We have to check this. Okay, so notice that it is a category of like improper integrals. So but in this case we have a defined limit. So what we are going to do is we'll assume that gx is equal to this function root x, 1 upon root x, right? But notice that it is a defined limit. So what we will do is we will assume this thing, 1 upon x minus a to the power half, which is equal to, as a is equal to 0 in this case, so we will get 1 upon x to the power 1 by 2, right? Okay, so simply you use the ratio test or limit test. You get limit as x is tending towards 0 positive of the quantity this fx, this is your fx, so it will be 1 upon root x plus x square upon gx, it is 1 upon x, right? This quantity. So when you solve it, you get limit as x is tending towards 0 positive of root x by root x plus x square, and when you solve this limit it will come to a finite value, right? You can check it also. When you check, it will be a finite value lambda. I'm not calculating it, you can calculate on your own, and if you solve it you get a lambda which is a finite value, right? This is a very simple limit, you can solve it. So since it is a finite value, which means from the ratio test that if this is convergent, that this will imply that this function will also be convergent. So notice that in this case mu is equal to 1 by 2, and since it is a case in which we know the both the limits, in this case it is a type 2 case, so which means in this case mu is less than 1, which implies that this fx will be convergent, right? This are your this was a nice question, and now let's see another question. Well, let me take another joke. Okay, so now we are going to see another question. This is a very simple question. I hope you all can solve it. Integral 0 to infinity of e to the power negative at of t to the power n minus 1 dt, right? It is very simple. You just assume at as equal to, you need to prove it is equal to gamma of n upon a to the power n, right? It is very simple. You just substitute at as equal to x, right? Notice that as x is tending towards as t is tending towards 0, x is also 0, and as t is tending towards infinity, x is also infinity, right? So we get this thing, right? So we get e to the power negative x of the quantity uh, x upon a to the power n minus 1, right? This thing, and when you substitute, when you do the differential part, you will get dt is equal to dx by a, right? So you get dx by a. So this is equal to integral 0 to infinity of the quantity x to the power n minus 1 into 1 upon a to the power n. Just add this power. This is a to the power n minus 1 and this is a. So adding it, it will yield a to the power n, right? And e to the power negative x dx, right? And just bring 1 upon a to the power n outside the integral since it's a constant. So you get this integral 0 to infinity of x to the power n minus 1 into e to the power negative x dx. And as we all know that it is equal to gamma of n, right? Gamma of n, hence proved, right? Okay, now we will see another question and then we will stop this lecture. So let's see if there is some nice question to be done. Well, we will see one more question which is very important and then we will end this lecture. Okay, so let me take another set of problem, then we will see. So there is one more question. The question is that gamma of n plus 1 by 2 is equal to root pi gamma of 2n by 2 raised to power 2n minus 1 of gamma of n. We need to prove this. So how do we prove it? Well, let's see. You know the property of gamma, that gamma of n is equal to n minus 1 into gamma of n minus 1. We proved it earlier, right? So we are just going to use this property and we will end up getting this result. Let's see how. So gamma of n plus 1 by 2 is equal to gamma of it will be equal to n plus 1 by 2 minus 1 of gamma of n plus 1 by 2 minus 1, right? Is it correct or not? Is it correct now? Okay. So we'll get n minus 1 by 2 of gamma of n minus 1 by 2, right? This is a simple mathematics, right? So you get n minus 1 by 2 and you apply this thing till the time we get gamma of 1 by 2, right? So we get n minus 1 by 3 by 2, you just solve it, n minus 5 by 2, like okay, let me tell only, else there will be confusion. It will become n minus 1 by 2 minus 1 of gamma of n minus 1 by 2 minus 1, right? This is the case, okay? So you get n minus 1 by 2 of n minus 3 by 2 of gamma of n minus 3 by 2, right? Is it simple? Right, okay. So let's evaluate it further and let's see what we are going to get. Sorry, I'm not well, so that's why. N minus 1 by 2 into n minus 3 by 2 into n minus 5 by 2 and so on and so forth till we get like we will end up getting like, so okay, till gamma of 1 by 2, right? We will come till over here, okay? Now let's see. Okay, so now we are going to get this thing, okay? So let's see, you can just bring this thing, you get 2n minus 1 into 2n minus 3 into 2n minus 5 and you are expecting to get 3 into 2 into 3 into 1, right? Into gamma of, what is gamma of 1 by 2? It's root pi, right? Root pi, yeah, upon what will be, there are n terms, so you get 2 raised to the power n, right? I will understood that how we are getting basically 2n minus 1 by 2 into 2n minus 3 by 2 and so on and so forth, right? So notice that it is going from n minus 2n minus 1 to 1, right? So in this case you will understand that there are n terms of 2, right? So that is why I have written 2 raised to the power n. So they are in multiplication, right? Okay. So let's see. So now notice that you can do it like this, 2n minus 1 into 2n plus 2n minus 2 into 2n minus 3, so on and so forth, into 3 into 2 into 1 into root pi. But what I've done is basically I've multiplied the even terms also, right? Okay, right? But we have to divide it also, right? So that the expression remains same, 2n minus 4 and so on and so forth till 4 into 2, right? Just bring 2 out of all the expression, you get let me erase this thing. So you get 2n minus 1 factorial, this is 2n minus 1 factorial, right? Upon 2 raised to the power n into, we will bring a 2 from this, you will get 2, you bring this, you bring 2 from this, you get again a 2, and it is going till n minus 1 times. So you are getting 2n minus 1 into n minus 1 into n minus 2 and so on and so forth of into root pi, right? You are getting this. You know how I proved that gamma 1 by 2 is equal to root pi? It's from the beta and gamma function I had proved earlier. You should remember that, okay? So 2n minus 1 upon this is n minus 1 factorial. So you get, and just multiply these two, you know, 2a into 2 raised to power b is equal to a plus b. We are just applying this thing. N plus n minus 1 into n minus 1 factorial into root pi, right? Now again, this is gamma of 2n. How? Gamma of n is equal to integral 0 to infinity of t to the power n minus 1 e to the power negative t dt. So gamma of 2n minus 1 is equal to integral 0 to infinity of t to the power 2n minus 1 e to the power negative t dt, right? That is the, that is why, which is equal to 2 gamma of 2n, sorry, is equal to 2n minus 1 factorial, right? And similarly we will apply this over here also. So we get basically root pi by 2 raised to power 2 raised to power 2n minus 1 of gamma of 2n by gamma of n, right? Hence proof, right? Now we will see one more question and then we will end the lecture, okay? So let's see, and it's really important questions, that is why I'm discussing it right now, and then I will make a one shot on all the chapters, the best question of all the chapters, right? Maybe in 1 or 2 days. So in that we will discuss everything, all the questions, all types of questions. So let's see the question. Wait, it is not in this one. I have to take another sheet. uh, yeah. This is this is the question. It states that we have to evaluate this in terms of beta function 0 to 1 of t to the power m 1 minus t to the power n into p dt. And like you have many questions from this, like they will ask 0 to 1 x cube of 1 minus x square to the power 100, like this they will said how to evaluate this in terms of beta and gamma, like that. So you can just derive this thing, and from this you will easily be able to derive this one. Okay, so I'm just telling the proof of this, and then you just substitute eminent for any value, they will you will be able to solve. Like in this sheet also there are 50% question of this form only, right? So let's see how we see it. So basically you are having this thing. So how do we convert it? Let's see. Let's assume t to the power n as x, right, for the time being. Okay, so when you find the, so in this what you will do is you can solve for t is equal to x to the power 1 by n, right? And notice that when t is equal to 0, x is 0. When t is equal to 1, then x is also 1. So we are getting 0 to 1 again. And what is t to the power n? It is x to the power m by n, right? This into 1 minus x to the power p. And what is dt? Dt is negative 1 upon x to the power x1 by n minus 1, right? I hope you are understanding it. So you are getting negative 1 by n over here outside, x to the power 1 by n minus 1 dx, right? So negative 1 by n 0 to 1 of x to the power, and you can just add the exponents, m by n plus 1 by n minus 1 of 1 minus x to the power p of dx, right? You got this. Okay, it's very simple. So you get negative 1 by n integral 0 to 1 of x to the power m plus 1 by n minus 1 of 1 minus x to the power p plus 1 minus 1. And notice that this is simply in the form of beta function. Let's see how. So we get, just put m plus n. If you have any confusion, then you can use m plus n as equal to, suppose, alpha, and p plus 1 as beta. So you end up getting negative 1 by n integral 0 to 1 x to the power alpha minus 1 of 1 minus x to the power beta minus 1 dx. And notice that it is clearly a form of beta function. So what you get is, you will get that it is equal to negative 1 by n of beta of alpha comma beta. Means this beta is different, this beta is different. So it will be minus 1 by n into, what is beta? Beta is simply equal to the integral. It is equal to beta of, what is alpha? Alpha is m plus n. Sorry, it was m plus 1 by n. M plus 1 by n comma p plus 1, right? This thing. I hope this is the case. I have to verify it because I think there is some mistake in this result. Wait, okay. Yeah, this is correct. This is the correct result. So you got this. I hope there is not a negative sign in this. Yeah, there will no negative sign. Sorry, because when you are calculating the derivative, it was like x to the power 1 by n. Na? So when it came down, it will be this x to the power 1 by n minus 1, right? So there will be no negative sign over here. That was the mistake. So it is 1 by n beta of m plus 1 by n of p plus 1, right? This is the case. Okay. So suppose you are given an integral in this question, it was given this integral 0 to 1. For example, this is the question, t to the power 5 of 1 minus t cube to the power 9 dt, right? You are given this. So how do we evaluate this? You just see that m is equal to 5, n is equal to here 3, n is equal to 3, and p is equal to 9, right? Just substitute the value. you get 1 upon 3 into beta of m plus 5 plus 1 by 3. It's 2. And what is p plus 1? It is 10, right? And you know that it is equal to 1 by 3 into gamma of 2 into gamma of 10 by gamma of 12, right? You solve it, you get 1 by 330, and that's the answer. And there are many questions of this form, right? So you just remember the proof, and from that you can solve it very easily. Okay, so now there is one more result which I need to tell, and then we will finally say bye bye. Okay, so now let's see. We know that the beta of mn was actually equal to integral 2 to infinity 2 to pi by 2 of sine of 2m minus 1 theta into cos of 2n minus 1 theta into d theta, right? We know this. So in that case, what we assume 2m minus 1 as suppose p, and 2n minus 1 as equal to p, and this as q. So basically what we do is that we solve for m is equal to p plus 1 by 2 and n is equal to q plus 1 by 2, right? We get this. So basically gamma beta of p plus 1 by 2 comma q plus 1 by 2, it will become integral 2 times the integral 0 to pi by 2 of sine of p of theta into cos of q to the power theta d theta, right? You are getting this. So from this, when you substitute it, you get so this is equal to basically gamma of p plus 1 by 2 into gamma of q plus 1 by 2 into by gamma of p plus 1 by 2 plus q plus 1 by 1 by 2. Like this you can solve it and you will get this. So I hope you all like the video. Please do like, share, subscribe my channel, and thanks. Bye bye. Take care.